Hello, Dr. McDonald. This is Ahmed, and this is going to be my submission for the final project. I hope you can hear me. I'm sorry I'm not taking a video because my phone broke and like literally it broke and I cannot use my phone. So anyway, I have the Bluetooth module of a receiver, and the point was I'm gonna transmit data from a terminal on my computer, like I have here, into the Bluetooth. It will transmit data via Bluetooth from my built-in Bluetooth in the laptop to the RN40, 42 Bluetooth module connected on the FPGA, and then when it receives the data, it will light up 8 LEDs depending on the type of data that we send. So this is my entire code here for the receiver, which is connected to the FPGA. It has an RX and output as LEDs. I know I said I was gonna use the motors, but like getting the Bluetooth to work was tough as it is. So I decided to just continue with LEDs to see the output easier. This is the code. It's gonna take a while for me to explain it, but uh, basically, there's a start bit, an initial start bit, and then it catches the rest of the 7 bits of data, and these are a bunch of timers here. Temp is the register that holds the value that will be driven to the LEDs. These are like a bunch of initializations for the counter, and this capture is a register that captures the RX data that comes in. So when you send one pulse of RX, there are 3 pulses of capture going at the same time, and it captures the data at the second pulse of capture. Um, and then there's a state machine here for RX. When RX is equal to 1 and done is 0, then do you control or not? Like, should the module take control of the data right now, or if it's done sending or not? And if RX is 0, done 0 control is 1, else control is 0. Um, and then here at pulse edge capture, if control is equal to 1 and done is 0, then the temp register becomes concatenated with the first bit of RX and the last the first 7 bits of the current register. And then it checks also every time at the positive edge of capture if control is high. There's a counter I, and if it goes above 9, then it should go back to 0. And then that means that done is 1, and if done is 1, then LEDs will take over the value of stored in the register temp. Else continue incrementing I, done is still 0. That's basically the module, and I created a TV over here for it. Clock 10 nanoseconds, reset RX. And I put a bunch of values for RX, and this is the time period for the 9600 baud rate that I have. So it's 104 microseconds. So yeah, this is the simulation that I have. And if we zoom in here real quick, we'll see all my RXs that I've input in. And then, that takes over with the control. And one by one, they get stored in the temp register. But maybe it skips like 2 bits because at that time it is low. So yeah, and it shifts. It keeps shifting all the time. So yeah, that eventually goes up to